fact, if I have to select two subjects which are the most important and which are most relevant for you in this course are regression analysis and simulation. So I think that we have done quite a lot on the regression analysis, and I'm sure that by now everybody has quite advanced level of understanding about that subject. And today I want to start with a simulation. And before we getting into some theoretical or conceptual aspect of a simulation, I just want to start with an example because that's usually the best way for us to get exposed to the topic. Let's think about aircraft manufacturer, let's say Boeing or Airbus, and the company is considering whether it will develop a new aircraft model or not, and it believes that I think let's make it a little bigger. The company believes that once they develop the aircraft, the company believes that it will be able to sell that aircraft for the next 4 years. So we have a 4-year time horizon. And there are certain assumptions about developing the new aircraft. For example, startup cost is kind of a fixed cost you have to pay upfront. And there is a variable cost if you build an aircraft, and it is assumed that that's going to be 75% of the selling price. And the selling price is, let's say, $35 million. We ignore these, 1,000. And there are also some fixed cost and depreciation. And also there is assumption about cost of capital and tax rate. And I hope that you already took some courses in finance and accounting, so you already know this concept, cost of capital and tax rate and so on and so forth. In addition, the company has some assumption about the demand, and it believes that it will be able to sell 10 units, 10 aircrafts each year for the next 4 years. That's the assumption. And then usually, if you want to determine whether you're going to do some project or not, you usually set up this kind of pro forma statement. This is income statement, right? Income statement, to see whether it is justified to develop the new aircraft. So we set up some sort of very simple format of income statement for the next 4 years. And then the first year, second year, third year, and fourth year, and the demand, the 10 units. And then the revenue is 10 times selling price, okay? 10 times 35 million. So we have $3,050 million, okay? But let's say 350,000. And we expect to have that revenue stream for the next 4 years. And then a fixed cost occurs whether you make the aircraft or not, because fixed cost implies that you gotta pay a certain amount, a fixed amount of money if you want to operate your plant. So we have a fixed cost, and variable cost is by definition variable, depending on how many units you make. And he said that variable cost is 75% of the revenue. So probably you multiply 0.75 to 350,000, then you will get 262,500. So we have variable cost. And then we also needed to take into account this depreciation, 10,000. And we have a profit before tax, meaning that you subtract 15,000, 262,500, 10,000 from 350,000. Then you will get profit before tax, which is 62,500. Okay? So it's very clear, very simple. And profit after tax implies that we need to pay tax. So the tax rate is 34%. So probably you multiply 0.34 to 62,500, you will get the tax rate. Tax amount, 21,250. So if you subtract this tax from profit before tax, you will have a profit after tax. And then what is it? Cash flow. You learn about this, right? Juan, what is cash flow? You remember? Did you take some courses in finance and accounting? Okay, so what is cash flow? Cash flow is just cash, right? Okay, cash. What is cash? Cash is just hard money. It's not, it's not some, book value, or cash is just actual, money on your hand. Anyone can explain why the cash flow is 51,250, which is different from, profit after tax? Can anyone explain this? Yunjung, can you explain that?
When we calculate the profit after tax rate, then depreciation is included, but that is not the real cash out, so we have to add depreciation to profit after tax.
Okay, so we add back depreciation to profit after tax, so we gotta have a 51,250. Again, cash flow implies whether you actually, have actual cash flowing in and out, right? And depreciation is not actual cash payment. That just the depreciation is just a book concept. In other words, the concept we use in order to determine this profit after tax. Okay, for the tax purpose, we usually consider depreciation, but when you try to make a managerial decision, you have to look at the actual cash, how much cash is coming in, coming out, rather than the profit in an accounting concept. So you actually add back this depreciation because this is not actual cash paying. So you add them up and you have net cash flow for each year. Very good. So we have cash flow 51,250 for each one of these next 4 years. And then year 0, we subtract 150,000. That is the startup cost, probably the R&D expenses, right? If you want to develop a certain new aircraft, you have to do some R&D, and it certainly costs money. So, they call that startup cost, $150,000. Okay. Now, we want to calculate the net present value. And I hope that everybody know what net present value is. Hey-Yun, what is net present value? You know that concept, right? No? It's your first time to hear about that? Net present value? Okay. Songjin, do you know what net present value is?
Calculate value with discount current value.
Okay. Okay. Hey, let's say I have $100 today, and I will have $100 next year. Are these $200 the same value? Not, right? Because if I have $100 today, it'll be probably $100.05 probably if the interest rate is 5%, right? So whenever we have money over a span of time, let's say for the next 4 years, even if the net cash flow is the same, but the real value of each one of these cash values different, because probably this one is much more valuable than that one, right? Because the same amount in the future, it's kind of less valuable because over time I can earn some interest. And so that's the basic concept. And therefore net cash flow meaning that we need to discount these factors with this cost of capital. Or if you have some interest rate, you can use interest rate to discount it back. In other words, if we believe this is 1 year, then we probably discount this by 10%, and this one is probably twice discounted for 2 years, and so on and so forth. I don't want to go over the details, but if you look at, you probably, because I'm not trying to give you some accounting lessons today or finance lessons today, so I just want to give you some basic idea about this net present value, and let me show you how you can do this net present value. In Excel, you have net present value function, right? So you just type in, for example, here, your NPV, and then you have a couple of things. First, rate. In other words, what is the discounting rate? And usually the discounting rate is cost of capital, so 10%. And then the values, how you want to, which values you want to discount. I want to discount these values. And therefore, if you look at this one, okay, let's say this is not, I don't need this now. So let's say, when I look at this one, net present value, NPV, D3 is what? That's cost of capital. And I want to use this discounting rate for those values in C17 and F17. C17 and all the way up to F17. So I want to take the net present value. And then because I spent $150,000 at the very beginning of this whole time horizon, so I don't need to discount this one because this is the right now, the current moment. So I just add B17, which is this one. So that's the net present value. When you look at this decision, when you look at this, this outcome, what is your decision? Jae-wook, what is your decision? You think that the company should develop this new aircraft or not? Aircraft, you want to develop this new airplane or not? Is it good for the company, or the company should not do this? Usually you don't have to think too long, because the criteria, when you use criteria, net present value, whenever net present value is positive, that means that you better do it, okay? All right. So when you say that you use net present value as your decision criterion, then usually when the net present value is positive, that's a good thing, because net present value takes into account all this, plus and minus at the same time, and the outcome is net present value. So the net present value for this particular project is 12,455. So it's good, right? Right? So let's say you are the CEO of this company, and someone presented this to you, and then the presenter says that the net present value is positive, and therefore it's good for us to do this project. When I say that, how do you feel about this? John, where is your nameplate? You forgot? Okay. So is this your first time to forget, or you forgot several times in the past? You usually bring? You sure? Okay. I recorded everything, okay? So, all right. So when someone says that the net present value of this analysis is positive, Juan, what is your reaction to that statement? You agree with that, and okay, I want to do the project, or what is your reaction? Yeah, it is positive net present value. So you don't have any concern, you don't have any, hesitation, just accept it. What kind of question you might have when someone gave you this? You don't have any doubt? Any concerns? You just accept it? Okay, what about the students? Hun, what do you think? When someone says that the net present value is positive, so we gotta do it, what is your response to that statement? What should we do? Or do you have any different ideas or different concerns, or you might have some doubts? No?
Firstly, I would check the assumption is right.
Okay. All right. Very good. Assumption implies that you predict something. It's not something completely determined. Assumption meaning that you assume some things. So in order to have all these numbers, you actually assume something. And that's the assumptions. And assumption is by definition not determined at all. It can change, right? So specifically, what assumption do you think you might have some question? Boyan, what assumption you think you probably have some doubt? Selling price? Obviously, right? We assume the selling price is $35 million, but there is no guarantee the selling price will be $35 million for the next 4 years. Okay? What else? Do you have any further, concerns? Nayan, you have some concerns about assumptions? Well, actually, you can question any one of these assumptions, right? You can raise any questions.
Cost of capital can change every year, I guess, depending on, I guess, if it's in like the metal industry.
Yeah.
Cost of metal changes every year. So that will be very fluctuating.
Okay. Very good. Very good. It's true that interest rate changes all the time, which implies the cost of capital will change all the time. So the point is that although we get this net present value based on assumed values, the assumptions are not fixed, are not deterministic. So we have to ask some questions. We have to raise some questions regarding whether these assumptions will be actually true or not. And I want to point out, let's say, the estimate about the demand. The company estimate the demand is going to be 10 units every year, but also demand is, usually uncertain. You cannot say that we absolutely sure that we will be able to sell 10 units for the next 4 years. So let's say we obviously needed to consider some uncertain factors regarding these assumptions. So let's say suppose that I have a big concern about this demand. So let's say I did some more study and I realized that I look at the historical data related with this kind of aircraft, and I try to figure out the demand distribution. And it turns out that I can have some probability distributions. So let's say, for the sake of simplicity, let's say it turns out that the probability distribution looks like this. In other words, it's not just 10 units I can sell every year. I can sell either 8, 9, 10, 11, 12, and the probability is equally likely. In other words, based on my historical data, I decided that the demand is uncertain, so I needed to incorporate this demand uncertainty by estimating this probability distribution. And then the question is, how can I incorporate this new feature into this analysis, net present value analysis? First of all, I needed to change this number because right now this number is just 10, which is fixed, but obviously it's not 10. So I want to change it to something uncertain, something changes all the time. I want to use some Excel function, and there is a function. I think that I already talked about this rand, right? In other words, that generates a random number between 0 and 1. Okay, so rand empty parenthesis, and if you push F9, then the random number changes all the time. So let's say this time the random number is 0.132, and now 0.22, 0.706, 0.0369, and so on and so forth. So every time you push F9, the rand function generates the random number, which is between 0 and 1. So let me give you just a very quick and very intuitive equation. If I want to incorporate this one, usually the minimum value is 8, and the maximum value is 12. And I know that the random number is between 0 and 1, and probability that random number will be 1 is 0 actually. In other words, it always less than 1, it always larger than or bigger than 0. And having said that, if I believe that each one of these demands occurs equally likely, then I have an idea to formulate the demand function. In other words, what I want to do is, let's say I want to have demand 8 plus 5 times random number. So if that is the case, if the random number is very small, very close to 0, then this whole number will be 8 plus something, right? And if random number becomes 1, then the whole number becomes slightly smaller than 13, right? Probably 12.9999 or something. So I can see that if I use this, then the number is larger than 8, but smaller than 13. So what I will do is, okay, this time the demand is 9.77, and now we have a 10.82, 11.16, and so on and so forth. It can never go over 13. It can never go down 8. But the problem is that this one is real numbers, but we want to have these integers. So I want to use another technique, which is I put int. So int means integer. Okay, so whatever number I have here, if I put int, I ignore the decimal points, and I just derive this integer portion of this whole thing. So if that is the case, what happens is that now I have 9 and 8, 11, 10, 9, 11, 10, so on and so forth. So if I use that function, if I use that, in other words, int, big parenthesis, 8 plus 5 times length, empty parenthesis, then that actually generates 8, 9, 10, 11, 12, and all this will be equally likely because random number is just equally likely in the range between 0 and 1. Okay? So if I do that, then I think that I can incorporate this whole thing into this demand function. Okay, good. So here, now the demand is between either 8, 9, 10, 11, 12. This one is same. This one is same. This one is same. And now, it's very interesting. What if the demand is not 10, 10, 10, 10, but 10, 8, 8, 8? Then it turns out that net present value is negative. So now I want to see another scenario. In other words, I generate one more set of random numbers by pushing F9. And it turns out that the demand can be also 12, 12, 11, 12, not 10, 10, 10, 10. If that is the case, the net present value is much bigger, much larger than the original one. So as you can see, sometimes what we have done is we incorporate the uncertainty into demand. And now demand follows this probability distribution. So it follows uncertainty. And as it happens, the net present value changes. So now we no longer say that the net present value of this project is 12,455, which was the original value, the base case. We started with the base case, and now we incorporate the uncertainty into this whole scenario. And now we have different number every time we push F9. So what should I do? What I can do is I write down this one. Okay, let's say how many try I have. Let's say first try, second, third, fourth, fifth, sixth, 9, 10, or whatever. And then my first try, let's say this figure. So let me see, I record that number. And then the second try, I have this one too. So I record this one. And then my third try, I have this. In other words, minus. And then fourth try, I have this. Let's say this one. And my fifth trial, I have that number. So let's say this is my sixth trial, which is quite high. And my seventh trial, which is not that large still. This is my eighth trial. This is my 10th trial. And finally, let's say that's my 10th trial. So now, as you can see, NPV changes all the time. I cannot say that the NPV of this project is 12,455 because whenever I look at the different possible demand distribution, the NPV changes all the time. So what should I do? I just do these things many times. And then I look at these NPVs. And probably I want to look at how this NPV is distributed rather than looking at only one point estimate. That's the main idea of a simulation. That's a simulation. When we have very complex uncertainties involved in the decision-making problem, it's very difficult for us to have some mathematical modeling that incorporate all these uncertainties. Usually, whenever we are faced with very complex real-world issues, the only possible way to solve the problem is usually using the simulation. And simulation is basically that. We incorporate the uncertainty, and then in this particular case, we calculate the NPV. But in order to have really great distribution, in order to have a reliable distribution, we probably want to have not just 10 times, maybe 1,000 times, or 10,000 times, or even 100,000 times. I want to do that. So what should I do? Well, it's easy. You can just write down these trial numbers, right? Let's say this one is that one plus 1, and you copy and paste maybe 10,000 rows, and then you start at 9 a.m. and push F9 10,000 times, right? If you do that, then you can record all these 10,000 different NPV values. That's one way, but that's very inefficient. So we have one of these StarTools software function that helps us to do that, and that's called at risk. Okay, so you go to at risk. At risk, that's the simulation software. And then for this one, everything is already set up, so this is very straightforward. What I needed to do is first I needed to define. For example, here, net present value is my criterion. Net present value is my criterion. I want to look at this, how this net present value changes. The most primitive way is you actually do this yourself 1,000 times. But we don't want to do that. So we want to use at risk as our simulation software. And then that's the net present value, which is our goal. We want to look at how this net present value changes as demand changes following this demand probability distribution. And then if you look at this, add output. That's our output from the simulation. So you select it, highlight it, and you go to add output. then it automatically name the cell net present value, and you just OK. You just OK. And then I want to do this simulation. You go to iteration. How many times you want to do this simulation? How many times you want to push this F9? Well, I want to do that 1,000 times. Okay. Then you choose 1,000 times, and the simulation. I have only one simulation today, and then you click Start the simulation. Okay, so let me do it again because the picture is not that great. Okay, I want to change the 500 times rather than 10,000, 1,000 times because it gives us, nicer histogram actually. So when I calculate the MPV 500 times, that's the distribution. And it gives us that the mean value is 12,025, which is very close to the base value, 12,455. But it not just to give us some point estimate, it gives us range estimate. And I will return to that point. When you have to make a decision, what's the big difference between point estimate and range estimate? Okay, that's how it looks. And then there are all these statistics, mean value, maximum, minimum values, 90% confidence interval, and so on and so forth. And if you want to see what about 1% here, what about 1% here, then you actually click here and then you move this to that direction, and then let's say okay, the bottom 1% NPV is minus 16,000. Okay, if I want to find out 99%, then you actually go click this and then move to all the way up to, okay, so 99% is 41,000. Okay, so basically I have now 98% confidence interval for this project. And the big difference is that in our base case, net present value, it was positive number, but now we can see that it might happen that the net present value is negative. So that implies a lot for the decision maker. All right, and I want to go a little further, and let's say I want to get rid of all this, and then I want to get rid of all this. I'm sorry, I think I don't need to do that. Probably I get over this, and okay, this is just a very intuitive, very primitive formula, but we don't actually need to do that at all, because AtLISC has a very good, very nice, okay. I think that's somewhat fixed. Okay, now I need to define demand a little further. We have defined distribution. You click define distribution. First of all, you highlight that you want to define the distribution for. You highlight this and go to define distribution, and then it will ask you about many different distributions. I think that there are only two probability distributions we learned so far. One is discrete distribution. The other one is normal distribution. So for the simulation, you also needed to understand these only two distributions. And in this particular example, that's discrete distribution, right? So let's say I want to go there, and then discrete distribution. And it asks about X table and P table. So I click this one, and then it asks me about X values. So that's X values. And then a P table, that's the P table. Okay, so then it automatically gives us this probability, distribution, 8, 9, 10, 11, 12, all the same, 20% probability. So I define this probability. Okay. And here, I want to say that K7, K11, okay, good. I will try this one. I'm not sure whether it works or not. 7, K7, okay, it doesn't work. So what I will do is here, I fix the column. And then okay, let me see that I can again. I think that 500 is better in terms of a shape. Okay, now we have different distribution. It is very natural because a simulation, whenever we have a new simulation, it generates a different set of scenarios. So the outcome is always changing. But at least we can see that the mean value is very close. In this case, 12,455. In fact, that's exactly the value of base case. Okay? Right? So that's the basic idea about simulation. And every simulation follows the same logic. You have uncertainty and incorporate the uncertainty into your Excel model, and then you do this simulation. So, any questions? I hope that you can find out how to use this at least. Okay, I will give you this file. I will upload this. I actually uploaded this one, but I can give you more details. But it's not more details. What you have to remember is there are two things. One is define distribution. Whenever you have uncertainty, you define the distribution and add output. Add output is the output is something I'm interested in. In this case, net present value. Or if you interested in some other values, you can define that as one of your output. So add output is just giving you what outcomes you want to look at. So in order to add output, you go there, add output, and it automatically names the column. And then if you want to define the distribution, you go to define distribution. And then actually you can see lots of different distributions. Let's say in this case, there is nothing. It will ask you about discrete distribution, normal distribution, and all other distributions. But again, you can forget about other distributions, only discrete distribution and normal distribution. Okay? Were you able to generate the same, histogram? I derived. If you did, that's great. Okay. Very good. Okay. Let me explain the difference between point estimate and range estimate I talked about. Right? For example, let's say I want to compare two different projects. We have project A, we have project B, and now let's say I want to compare these two projects with net present value. This is mu. And let's say the net present value of project A is 20,000 and project B is 15,000. If that is the case, which project you want to choose? Jiwoon, which project you want to choose? A. Why? Okay, MPB is bigger, right? The MPB for A is bigger than B, so that's the so-called point estimate. Point estimate. In other words, we estimate something at a particular value, MPB. And now, let's say I want to incorporate the nature of feature of uncertainty, let's say standard deviation. So the standard deviation for this is 15,000 and this is 4,000. If you have this additional information, does that make you change your mind? Okay, that's the question. When you have extra information about the uncertainty. Aram, can you have this extra information about uncertainty? Jiwoon said that if we have this information, it is obvious to choose project A. But when you have extra information about uncertainty, does that make you change your mind? Okay? Then which one you want to choose? Why? Okay. All right. So let's draw the two projects. Let's say one is 1,500. The other one is 20,000. So if we have to make a decision by looking at this point estimate only, it is obvious for us to choose project A. Probably no one raises any question, no one raises any doubt about that. But suppose we now have extra information about uncertainty, then that means that this one will look like this. That's B. And A will look like this. This is A. So if I have some sort of a 99% confidence interval, what happens for project B is 99 confidence interval is, let's say this is 3,000 and this is 27,000. So the project B, 99% confidence interval is probably between 3,000 and 27,000. Whereas if we look at the 99% confidence interval for A, it can be, let's say, minus 25,000. And it can be, let's say, 65,000. So that's the range we can expect from project A. And this is obviously what I did was this is 15,000 plus minus 3 standard deviation. And this one is 20,000 plus minus 3 standard deviation. So now, the decision is not about A and B. It's not straightforward. Now it involves the decision maker's subjective judgment. So decision making problem is no longer an objective process. It is more subjective process, because some people say that because project B, even if the worst case project B gives me 3,000 positive profit, so I want to go ahead with B. But some people might say that, okay, even if A, the most pessimistic scenario is very bad, but I want to look at positive side. In other words, the positive side is 65,000, which is huge. So I want to bet on A. Is there any one right answer? No. If you want to choose A, you probably are an aggressive decision maker, risk seeker. Okay? For example, we call that as risk seeking. Risk seeking, or sometimes we call that very aggressive decision maker. Whereas if you prefer B, you are a little bit conservative decision maker, or risk averse decision maker. So now the decision making problem is not an objective endeavor, it becomes very much subjective. So we have now NPV plus decision makers attitude toward risk. That's utility. So if you recall the decision tree analysis, we used the net present value. That's expected monetary value. When we talked about expected monetary value, that's basically net present value. But we did not try to incorporate the decision maker's very subjective attitude toward the risk. But if you look at this, now we are paying attention to the decision maker's subjective attitude, emotional, psychological responses to the risk itself. So when we add this one to the expected monetary value, or NPV, it's going to be utility. And now the decision making problem is no longer an objective endeavor, it is more like a psychology, because we have to understand the mindset of the decision maker, and that's the utility theory. And how can we have this kind of perspective? Simulation helps us to see the problem from this perspective. So simulation gives us extra power to make a decision by giving us range estimate. Okay, so adding all this, we are not just point estimating, we have now range estimate, and that's what the simulation is giving to us, and that's the meaning of the simulation. Okay, very good. So why don't I go over another simulation problem? Number 35. And just to read through these whole things. It seems a little bit complicated, but if you try to understand this problem step by step, it's not that difficult. It's a very realistic problem, especially, let's say, in the fashion industry or footwear industry, This is a usual situation. Lamington's trying to determine how many dresses to order for the spring season. And based on our historical data, we know that the demand follows a normal distribution with the mean 400 and standard deviation 100. The contract, you gotta have contract, right? Usually Gap and Benetton and Uniqlo, these companies do not make their own goods themselves. They do not usually have their own plant. So they have to work with outsourcing partners. And then at the very beginning of the season, they usually set up contract. In other words, they needed to reserve the capacity. So how many units of dresses we're going to order? That's a reservation. You needed to have reserved the capacity for the season. So you can reserve capacity. Let's say you can reserve X units of capacity. So let's say I want to reserve 450 units capacity. Once you have that reservation, sometimes there is a minimum amount you have to buy. And in this case, it says that 80% of the capacity you have to buy no matter what. Because otherwise, the outsourcing company should take all the risk, right? And then there are some information about the selling price, 160. And when you buy this dress from, in this case, Hudson, you pay $50. But if you reserve a certain amount of capacity, and if you do not use the capacity, completely, then you have to pay penalty cost for the capacity you reserved but you did not use. And that's the example. Then the question is, how many units of capacity should I reserve? Should I make a reservation? As you can see, this is a very simple problem, but very interestingly, no mathematical model can answer this question, even if this is very simple, very straight problem, because it involves many different layers of uncertainties at the same time. So even if the problem is very small, in the real world, the problem might involve many different types of uncertainties, and it's not easy at all to formulate some fixed model to solve or answer this kind of a question. So the best way to tackle this issue is using a simulation. So let's do it together. This is 35. Okay, so usually when you do this simulation, you usually set up some Excel template. And let's say we have all this information. I needed to copy down this information into this Excel template. So I want to have some information about demand distribution, mean and standard deviation, because we assume that it follows normal distribution. Unit selling price and the jeans charge, unit penalty cost, and minimum capacity percentage, we set at 80%. And I want to test different types of capacities. So I want to start with the 400, 450, 500, 550, and so on and so forth to see which capacity is the optimum. And then I do the simulation and I calculate some numbers in intermediate steps before I get the profit figure. So usually simulation, you start with establishing this Excel template. And just, first step is write down all this information you already have. So it's straightforward. We know that the demand follows normal distribution 400. You put down the number here, 400, and then the standard deviation 100. And we know that the selling price $160 and the charge $50 and penalty cost is $5 for 1 unit of unused capacity. Minimum capacity percentage is 0.8, and capacity is something I will determine whether I have, let's say, we start with the 400. Okay, good. So that's just straightforward. I just put down all this information in the problem statement, and then I capacity 400, but I will change this capacity as becomes necessary. Now simulation demand. This one first, what should I do? I go to at risk and I define this as normal distribution. So I define distributions and go to normal distributions. And then what is the mean value? Mean value is 400. Standard deviation 100. I click there. So I define this, the demand. This one follows normal distribution with B4 400 and B5 100, mean and standard deviation. Okay, so that's my distribution, demand distribution. So I click OK and delivered. We got to be a little bit careful here. So let me try to make it understandable as much as possible. And let's see whether you can follow the logic. Actual delivery meaning that actually how many units of dresses I got from my outsourcing partner. It's a little bit complicated, but let's say we have some line. Let's call that as demand. And there are two things. First, I reserved capacity reserved. That's X, capacity reserved X. And then this is minimum capacity, minimum I have to buy. So 8 times X, 0.8 times X. If, let's say demand is D, if demand is here, how many units do you think I need to buy from my outsourcing partner? I can buy up to X because that's my reserved capacity. So I buy if demand is larger than X, then I can get X. Right? Because I cannot get more than I reserved. if demand is here, in other words, if demand is less than 0.8x, then how much I get? I should get 0.8x, because that's the minimum amount I have to buy. Okay? And if demand is between 0.8x and x, then how much I get? I get exactly demand. So depending on the demand, depending on the amount of demand, I have to calculate how many units actually I get. In other words, that's delivered. Actual delivery. Actual delivery. Let's call that L. If that L, then L depends on the demand. If the demand is larger than capacity reserve, then the delivery will be X. If the demand is less than 0.8 times X, then the delivery is going to be 0.8x. But if the demand is between these two, the delivery is going to be D. So that's the most complex area we have to put. Once you understand this logic, then I think that it's easy, it's straightforward for you to fill out all these blanks. Okay? So we have actual delivered amount, that follows the logic I just showed you. And then a sold, meaning that minimum between demand and delivered. And revenue you can calculate by multiplying this sold and the selling price. And the charges, delivery times 50. And then the penalty cost is obviously the unused capacity times 5. And profit, you subtract all these costs from the revenue. Then you will get the profit. Okay. So I will upload this file and with all this formula, and you can see what's going on here. And I hope that you follow this logic. But I think that the basic logic is similar with our discussion on this aircraft manufacturing. So I think that this is something we need to look at. So what I want to do is I want to make sure that everybody understand how to do the simulation with this template. That's our goal for this class. So everybody should know, everybody should understand how to define this demand. Okay? So let me just go over one more time probably. Okay? We remember that we started with this one, right? We started with this basic model, and this is called base model, because whenever you want to, make a decision, you need to start with the base model. And base model using basic assumptions. And then base model usually gives you the point estimate. Okay? So I hope that everybody understands how we get this number. And then we have to ask a question regarding these assumptions. And our biggest concern is about the demand. So the demand is not fixed. So we have to change the demand. And let's say we already said that the demand follows this distribution, okay? So let's say okay, so now we want to change the demand, and how we can do it? We go to add list, and then this one, you select this one, and then you define distribution, and that's discrete distribution, and then you select this part, and then it gives you the table. So that's x value, that's p, probability. So I choose this column. So for the x, I choose this, and then for probability I choose this, and then I OK. Then how come this can be 20? Because I have this one, right? Okay. So now I want to copy this, but because okay, you do the same thing for second year, third year, fourth year, and then you have all this demand converted into uncertain figures, uncertain numbers. Okay, so I think that you need to fix the columns. You need to fix the columns. Okay, you copy this, paste all, then I think that I have defined all these probabilities for this demand. And then what I'm interested in is this one, net present value. So I define that as my add output. Okay, so good. So then I want to get rid of all other things. Okay, so I have this one, and then go to add list, and iteration, how many times you want to do, 500 or 1000 is okay, but let's say 500, and then you start the simulation. I think this is not good, so let's do it again. It's not good either. I think strange. Okay, whatever. You do the simulation, and then if you have more iterations, it can give you more detailed pictures. But whatever you do, you will have all this, Okay, so depending on this, the whole thing, you probably get some different numbers. But I think that it's doing some funny things. But the simulation is basically you define this, probability distribution and find out net present value, and then you use define distribution and add output, and then do this start the simulation, and you will see the outcomes. Usually that's range estimate. Okay, and I tried to give you this number 35, but it turns out that a little bit complicated, but I hope that you can do some exercises with it. All right, so today's goal is to make sure that everybody follows this one and everybody can duplicate what I have done today, because that's very important. That's the very basic of simulation. Any questions with the simulation? Can you do this if you given a similar problem? Okay, so I hope that you go over this one, and then I will upload this file so you can follow what I have done. And that's the basic meaning of a simulation. Simulation usually deals with uncertainty, and uncertainty is expressed with probability distribution. So simulation helps us to see the range of outcomes, so that we can make a better decision. All right. I hope that we have more time to discuss the simulation, but I think that today's example is actually the very basic of simulation. And I already said that all the other more complicated simulation and more complex simulation is based on the same assumptions, based on the same mechanisms to do the simulation. And what we have done today is the backbone of any kind of simulation. Okay, very good. So, as I said, we learned a lot, many complicated concept and complex sometimes theories and some very important empirical evidences and so on and so forth. But this course is about managerial decision making, and I think that all the tools we learned so far in one way or another to help you to make a good decision. But as I emphasized, all the basic probability and basic statistics, we learned those topics because we want to learn regression analysis and simulation. But obviously, I never covered the simulation to its full length in the previous years, but I think that this introductory level can give you some idea about the simulation. Very good. So I think that today is going to be our last lecture. So, I just covered the simulation at the very beginning part of simulation. But I think that, again, this can give you some idea about what simulation implies. And as I said, today's goal is to make sure that everybody can do the same thing as I did with this template. And I think that we recorded this lecture, and also I will give you the template to you so that you can go over this. And if you have any further questions, you can ask your TA or you can set up a meeting with me. That'll be fine as well. Very good. So I think that we're going to have next week we start the final exam week, right? So there will be a final exam, but the final exam will have two questions, two problems. One is again regression analysis, but I will ask you more about these dummy variables. So I want you to pay more attention to dummy variables. And then second problem will be simulation. and I will give you the same template with the different numbers. And I ask you to do simulation as we did today. And then I will ask you about what implications can you derive from that analysis. And probably I will ask you about your point estimate and range estimate, which I already talked about today. So the final exam is not, I think that it'll take maybe 1.5 hours probably, not the full 3 hours. And it will have only 2 questions. And then again, simulation, the question is this. The problem is exactly the same, but different numbers, and probably have some different assumptions. So if you can follow what I did today, you would have no problem at all, I hope. Okay? Very good. And I know some of you who do not have any background in statistics and probability found it very difficult to follow some of these topics we learned in this course. But again, I think that the main primary goal is to help you to have some more objective perspective, more quantitative perspective to look at managerial problems and managerial issues, rather than getting the actual answers to certain problems. And in that regard, I think that most of you did a reasonably good job, and then I really appreciate your hard work and effort. And I'm sure that whether you did good or bad in your previous exams, I hope that you can do your best for the final exam. And if you think you didn't do a good job in the regression analysis, I think this is going to be another chance for you to demonstrate your competency. And that's it. So I think that this is the end of our lecture. And I hope that you work harder and you accomplish your goals and objectives when you enter this business school. Okay? I again appreciate your effort and hard working. Right? Good luck to you.